So now we're moving on to systems of equations, and this section is about systems with two variables. Before we start getting into the section, I want to talk about an application of this. Let's say you open a new business, and whenever you first start your business, say that first month, what do your expenses look like? Your expenses are pretty high, right? But over time, hopefully those expenses start to decrease a little bit. Of course, it will level off at some point because you still have to pay mortgage or rent or your phone bill or things like that. So over time, it would probably start to level off a little bit. But when you first start, it's pretty high. You have to pay all your deposits, buy all your furniture and all your merchandise, but then it does decrease over time. Well, that very first month, what does your income look like? Well, that very first day, your income's really not that great, right? Maybe not many people know about you. But over time, hopefully that income starts to go up a little bit, right? So what do we call this point right here? This point right here is called the break-even point. So before the break-even point, you're kind of operating in the red, right? Your expenses are higher than your income. But once you get to that break-even point, after that, we hope that your income is higher than your expenses. That break-even point is what we would call the solution to this particular system of equations. Okay, so there are actually lots of ways you can solve a system of equations, and we're going to talk about 3 of them in this section. And the first one is just by graphing. So to work this first problem, I'm going to remind us of different ways we can graph lines. Remember, you can always just make a table and plot points. There's nothing wrong with that. But for this, I think what I'm going to do is slope-intercept for this one. And then for the other one, I think we will use our intercepts to graph the line. Just to give us a review of different ways we could graph lines. So if we start with 3x minus y equals 2, to get it into this form, we need to get y by itself. So I'm going to subtract 3x and divide everything by -1. So we have y is equal to 3x minus 2. In this equation, your slope is 3. Or 3 over 1. Remember, that's your rise over run. And then your y-intercept is b, this part right here. So your y-intercept is the point 0, -2. So we go to 0, -2. Then we rise over run. 1, 2, 3 over 1. 1, 2, 3 over 1. And of course, we sketch the line. Whenever you solve a system by graphing, you want to try to be as exact as possible. Okay, so that's one line. Well, let's graph the other one using intercepts. So we have x plus 2y equals 10. Remember to find the x-intercept. You let y equal 0. So we're going to have x plus 2 times 0 equals 10, which means x is 10. So our x-intercept is the point 10, 0. To find the y-intercept, you let x equal 0. So we have 0 plus 2y equals 10, which means 2y equals 10. And when we divide by 2, we get y equals 5. So the y-intercept is the point 0, 5. So we can plot these 2 points, 0, 5. And 10, 0, draw the line, and we can see pretty clearly what our solution to the system is. The solution is right there. It's the point 2, 4. That would be the solution to our system. Now you can imagine that solving by graphing is not very exact. Like, what if I didn't draw straight lines? Or what if our solution involved fractions or decimals? We wouldn't know what those are. So graphing really isn't the best way to do it. But we always start with graphing because it helps you visually understand what it means to solve a system of equations. Now you can also, you can also check your answer. If this is the solution, we can take 2 for x, 4 for y, and substitute them into both equations. So let's do that real quick. We have 3 times 2 minus 4 equals 2. We want to know if that's true. 3 times 2 is 6, minus 4 equals 2, and yes, that one works. But just because it works for one doesn't mean it works for the other. For it to be a true solution to the system of equations, it has to be true for both equations. So the other one is x plus 2y equals 10. 2 times 4 is 8. 2 plus 8 is 10. So that one also works.